Dr. Aviv's practice test for test number 2. So looking at how people generally solve these equations looking for nodal analysis with voltage, on YouTube, people usually follow 4 basic steps. First one being they create a reference node, which is one of the ones down here, and set it to ground. The second one is they make sure that all of their nodes are clearly identified. So here they're already marked for us, node 1, 2, 3, and 4. Then they make the equations and they solve. So looking at this first node here, we have plus and a minus 6 volts. That means that there is 6 more volts flowing through here than there is down here. And look, this is set to 0. So we have 0 volts here, and we have 6 more up here. The way that I generally like to write this equation out is V1, which is higher, minus lower, minus 0 is equal to 6 volts. V1 equals 6. So this higher minus lower here is really the key, and we're going to use that in this second node as well. So looking at this right here, this is our V2, and we have plus more 12 volts going through here than we do here. And so following higher minus lower, we have V3 is higher minus V2, which is lower, equal to 12 volts. And for this third node here, let me erase this. This is a little bit more complicated because here we can write everything like normal, like we did, but we have this 12 volts in the center here, so we don't really know what's going on in here, and so it's more difficult to solve. But what we can do is we can do a super node, and we can combine both of these nodes right here. And what happens when you do that is everything leaving this super node is equal to 0, the sum of the currents. So let's put this whole super node together and set all of the currents equal to 0. So we do this the same way following Kirchhoff's current law. So let's label this I1, I2, I3, I4. Then we can say that I1 plus I2 plus I3, all these currents equals 0. So, okay, let's start solving for these equations, plugging them in. So I1, looking here, so it's going to be the higher one. If you're not really sure which one is higher or lower, generally you start with the node that you're at, and then you look, it's going away. Okay, so, sorry, that wasn't explained correctly. Okay, so we have this current flowing out that we've labeled it flowing out, and that means that the current is always going to be higher here than it is down here. So this is higher and this is lower. So that's why we are following the higher versus lower, V2 minus V1, and then over resistance. So this is current, remember our equations, I equals V over R. And what is V? V is higher voltage minus lower voltage. And so that's what this is. I equals higher voltage minus lower voltage over resistance. Yay! And so that's what this is. So looking for I2. I2 is down here, and we have the higher V2, and then this is going to be minus 0 because of our reference node down here, over 4, plus I3, which is here, so we have V3 higher minus lower, which is 0, over 6, and last one we have plus V3 minus V4 over 4, and that all equals 0. And so the professor writes that a little neatly. So V2 minus V1 over 3 plus V2 over 4 plus V3 over 6, and last but not least, V3 minus V4 over 4 equals 0. So it's the same thing, the current law, but we just plug in and are trying to find our voltages. So for this last node here, we can do it the same way as we did before, so higher minus lower. And so let's say that we're looking at it flowing out. The current is flowing out. So the higher voltage, V4, minus the lower voltage, V3, over 4, plus higher minus 0, which the lower one, over 2, equals 0. Perfect. Alrighty, so we already were working on supernodes, so this one is actually way simpler. So this is the supernode here he made for us, and find the equation. So like we did before, all of the currents flowing out of the supernode are equal to 0. And so we have this one here. We can just do I1, I2, 3, I4, I1 plus I2. Alrighty, so I1 is negative 6, because the current flowing in here is going against the current, so it's negative. This was covered on the last test. And then I2 is going to be the higher one, V1 minus 0 over 6, and this I3 is V2 minus 0 over 12. See, our reference node is already here for us. And then the last one, I4, is going to be V2, oh, no, not V2. We already have the current here for us, and the current is flowing out, so that's going to be a plus 4 equals 0. Alright, and this one looks pretty standard, the same thing. Here's our big colossal node, and we have current flowing out there, there, so we should have 5 equations. 1, 2, 3, 4, 5, yep. Okay, so looking at this one here, we have V3 plus 12, so just look at this as like one big unit. That's just the, I guess, how you could look at it, the name, the quantity. So, you know, we can put that in parentheses. So that minus, so our higher, because this is our reference node down here, our higher minus lower. And so down here we have this minus and plus, and so that means that this is less than here, minus 6 volts. So we have our, this is higher minus lower, and our lower is going to be negative 6 over resistance, which is 2. Alright, and then which one does he do next? It looks like he does this one over here next. Okay, so same thing, higher V3 plus 12 over 2. Here's a resistance, and then this is minus our lower, and so we have plus 12. So this is going to be minus a positive 12. And so that's how he gets that one. the next one here, he is looking at v3 plus 6. Where the heck is that one? Okay, so it must be this one here. And so our higher v3, and then this is minus a negative 6 over resistance, which is 1, and so that simplifies to v3 plus 6 over 1. And this next one here, he does right here, so this is going to be v3 and then minus the lower, and so up here we have positive 12, so v3 minus a positive 12 over resistance, which is 1. You can simplify that as v3 plus 12 over 1. And then we have our last but not least is this one here. So we have v3, the higher minus the lower, which is 0, over 2, and equal to 0.